Hello there. Today we are going to start control systems. In this small video, we are going to see some control system examples and try to acquire the ability to differentiate between open loop control systems from the closed loop control systems. So let us see first the definition of a control system. A control system consists of subsystems and processes or plants assembled for the purpose of obtaining a desired output with desired performance given a specified input. So, the important things here are subsystems or plants, desired output or reference input, that is this, and the performance. Performance in a crude way can be understood as the difference between the desired response and the actual response. Now, if the difference between the actual response and the desired response is large, then we say that the performance of control system is bad. And if the difference between the actual response and the desired response is small, then we say that the performance is good. Now let us see an example. Let us see a very common example in our houses. This is a bread slice toaster. Now here it is used for toasting bread. Here the reference input is the desired amount of browning of bread, and the output is the actual amount of browning of bread. So the desired amount of browning is selected by this regulator knob, which is a transducer, and then the mechanism inside the toaster is started by pressing this lever downwards. The process ends with popping up toads. Let us see a functional block diagram of this process. This is a functional diagram. These are some blocks which represent a part of this whole process. So, these are the general blocks which can be found in any control system, or there can be some additional blocks. These are some common blocks. So we can identify these blocks with our example. So here this block input transducer is represented by this regulator knob. Hence there are some internal mechanism that are doing this job. So here we have a output, that is the browning of toast, and we have some input, that is the desired level of browning. So this is an example of control system. Let us see the next example, that is a liquid level system. These liquid level systems are very common in industries such as chemical industries, steel industries, etc. Now let us see a liquid level system. Here a tank is present and there is a knob which controls the inflow or outflow of liquid, and control in that way it controls the level of liquid present in this tank. There is also a level sensor or a height sensor attached to the tank which shows the height of liquid present in this tank. Now suppose there is a person who controls this knob for getting a desired level of liquid in the tank, but does not have access to this level sensor. He cannot see the level sensor. So suppose we have a desired level of 5 units. So the man controls this knob, sets it at 5 so that he gets a level of 5 units at the tank. Now the knob is approximately at 5. This is the level of liquid in the tank. So we can read the level sensor showing 3.07. Now this is the actual output and it is different from what is desired level, that is 5. This is an example of open loop control systems. So we have a desired level, we are giving some input to the system. Here this tank and knob system is representing our plant, and the actual output is shown by this level sensor. Now let us consider the liquid level system and make a functional block diagram of this system. This is our basic block diagram structure for a control system. Here we can adjust our example and show the respective blocks. Here the knob and tank system is representing a plant and liquid level sensor is representing an output transducer. Our desired level is the reference input. So here some important uh, issues are that there is no feedback from this output transducer to this reference, this controller, the input side. The person moving the knob does not know what is the exact output, the actual output. So this is an example of open loop control system. It does not have any feedback and the performance is also not good. Why it is not good? Because we have seen that the reference input or the desired level was 5 and the actual output or the level actual level of liquid in the tank was 3.007. So there is a difference between the desired level, that is 5, and the actual level, that is 3. So we conclude that the performance is not good for of this control system. Now suppose the person who is controlling this knob have some knowledge about the actual level of liquid. That is, some feedback is given from this point to this side. Let's see what happens then. Now we can see here there is a feedback. Now this controller or the person who is controlling the knob has some knowledge about the reference input and the actual output. So according to that, he adjusts the knob so that the desired level is achieved at this point. This is an example of closed loop control system or a feedback control system. Control systems can be identified in many of our day-to-day activities. One such activity is cooking. So let's see an example of control system in cooking in our next slide. This in this activity we are considering cooking, adding salt in our dish. Suppose the reference input is the desired amount of saltiness in the dish. The output is the actual amount of saltiness. Suppose a young girl tries cooking and adds some salt in the dish as per her wish. Here, the actual saltiness depends on her efficiency and skillfulness. It may go wrong or it may be right. Next, her mother comes and tells her to taste the food and adjust the salt level according to it. Now, can you identify which is an open loop control system and which is closed loop? Well, this is the open loop system and this one is closed loop. So why? Because in this system we are not tasting the food. So only we know the reference input and we give a control, add the salt in the dish, and it depends on the skill of the cook that the food is having right amount of salt or not. But in this case, we are tasting the food and thus we are giving a feedback of the actual output and then adjusting the input according to that. So this is a feedback control loop. Now let's see another example. The action of steering an automobile to maintain a prescribed direction of movement is a feedback control system. Here, the prescribed direction is the reference input and this one is the output. The driver's eye performs the function of comparing the actual direction and the desired direction or the reference input. The eye transmits a signal to the brain and the brain in turn signals the arms of driver to turn the steering wheel in such a way that the actual direction comes in line with the desired direction and controls the direction of the car. There are many examples of control systems in biological systems also. Let us see some of these examples in a human body. The very common examples are the body glucose, the blood glucose concentration control, and the body temperature regulating system. Now, in this blood glucose concentration control, the pancreas and insulin work in coordination with the brain so that a healthy level of blood glucose is maintained in the blood. And in human body temperature regulating system, our skin, sweat glands, and blood vessels do the task of controlling the temperature of the body. Let us see an simplified block diagram representation of this regulation system. You can see this diagram is much complex to understand. We can see the important things here only. This is our reference input, that is 37 degrees centigrade. This is the desired level of temperature to be regulated in the body, and many physiological processes take place with the help of the brain and endocrine system so that this temperature is attained by the body. So control systems is much common in in our daily life, in engineering, and most obviously in air traffic control and in satellite communication, missile guidance, etc. So there are some other examples of control systems. The list of these examples can go on and on, but I cannot write them all on these slides. So I think that we should stop here. And so with this small video, I hope you can identify control systems in your daily life and around you. Now, you should be able to differentiate the open loop control systems from the closed loop control systems. Now, let's summarize our observations. So, control systems are common. You can find them everywhere around you. When the output has no effect on the control action, the systems are called open loop control systems. Mm, the the closed loop control systems are systems where the reference input and the feedback signal is fed to the controller so as to reduce the error and bring the actual output close to the desired output.